Hi everyone. Today we're going to talk about section 5.2, which is adding and subtracting polynomials. Before we go on to 5.2, I want to just do a brief review of 5.1, what we did yesterday in defining polynomials. So the first thing I have on the screen is the question, describe the following polynomial, 2x to the fifth minus 3x squared minus 7. So for the solution to that, describing that polynomial, we have a number of terms. So how many terms is the polynomial? Well, it's got 2x to the fifth, which is a term, and minus 3x squared, which is a term, and minus 7, another term. So the total number of terms is 3. And if it's a 3-term polynomial, what's another name for this? Well, it's got 3 terms, so it's called a trinomial. Do you remember that? So trinomial has 3 terms. A binomial has 2 terms, and a monomial has 1 term, 2 terms. And a monomial has 1 term. There. And to get the polynomial coefficient, so the next question is, what are the coefficients? You take the numbers in front of each term. So for the term 2x to the fifth, well, the coefficient for that is 2, because it's the number in front of the x to the fifth. And in this case, minus 3x squared, well, the coefficient is minus 3. So you have to be careful to remember the negative sign if it's a minus. And the last one, the coefficient is minus 7. Because remember, we could say it's minus 7x to the 0. So the minus 7 is your coefficient. Okay, and then the next thing is, what is the leading coefficient? So the leading coefficient is the coefficient of the leading term. And the leading term is determined by the exponent. So 2x to the fifth has the highest exponent of any of the terms in this polynomial or trinomial. So the leading coefficient then is going to be is going to be 2. And then the next thing is to find the degree of each term. And you want to add the exponents in each term to get their degrees. So for instance, 2x to the fifth, well, that's 5. The first one is 5. The first term is 5. The second term, the degree is 2 because it's 3x squared, minus 3x squared. And in the last term, the degree is 0. We already talked about that. And then the leading term is the term that has the highest degree, so that would be the 2x to the fifth. And the degree of the polynomial is the degree of the leading term. So the degree of the polynomial is 5. Now down here it asks us for the constant. And the constant is this thing at the end, this minus 7, which would be x to the 0 implied, but the constant is minus 7. Okay, now the next section we're going to work on is just about manipulating the polynomial. So the question is, write the polynomial in standard form, which means each term in descending order according to degree. Identify the leading coefficient. So if we look at the terms here, we have 3 terms, right? 1, 2, 3, so it's a trinomial. And the degree of each term, well, the degree of the first term is 4 because it's d to the 4th. The degree of the second term is 0 because it's just a constant. And the degree of the third term is, well, it's d to the 2nd, so its degree is 2. The leading coefficient is the coefficient of the term that is the leading term. So the leading coefficient is minus 4. So we know that minus 4d squared then is the first term in the polynomial. Pardon me, 4d to the fourth. And then the next degree is squared, d squared. So the next term would be minus d squared. And then the last term is minus 1. I think that said minus 1. So this is your answer. Minus 4d to the fourth minus d squared minus 1. And that's in standard form because it goes from the highest exponent to the lowest. Okay, the next problem is we're asking you to do the same thing. So it's 2a plus 4a cubed minus 5a squared minus 1. So the degree of each term, well, we're looking at the a's, and we can say that, do the blue. So the first one, 2a, the degree is 1. 4a cubed, well, the degree is 3, because it's a cubed. Minus 5a squared, the degree is 2, because a is squared, and minus 1 is 0. So the leading coefficient is the coefficient that has the highest degree exponent. And the thing that is the term that has the highest degree exponent is 4a to the cubed, a cubed. So that's the first term. And then the second term is the term that has the next highest exponent, which is 2. So that's minus 5a squared. And then the third one is the third highest, which is 2a plus 2a. And then your constant. So that's that polynomial written out in standard form. Okay, so now let's get into a little bit of the adding and subtracting of polynomials. So the question here says, find the sum of 6x cubed minus 4 plus negative 2x cubed plus 9. Well, what I like to do is, it says here, group like terms. So I like to group things together. So we'll put 6x cubed, and this is a plus minus 2x cubed, so we have to do that, because the plus, this is a minus 2x cubed. And then we're going to do plus, because that's what's going on here. So we have a minus 4 and a plus 9. So now I've grouped the x cubes together, and I've grouped the constants together. And so we combine the like terms, which is 6x cubed minus 2x cubed gives me 4x cubed. And then minus 4 plus 9 is minus 5, so that's plus 5, so that's plus 5. So 4x cubed plus 5 is the simplified answer. Okay, let's try another one. And this time I'll put them on top of each other like they do in the book. So 8y minus 4y squared plus 3y minus 9y squared. So if you have 8y, oopsie. Okay, so if you have 8y minus 4y squared plus 3y minus 9y squared. Well, if you add those together, you add the like terms. So 8y plus 3y is 11y. And minus 4y minus 9y is minus 13y squared. So I meant to say minus 4y squared minus 9y squared equals minus 13y squared. And that is your answer, except that we need to put it into standard form. And that is minus 13y squared plus 11y. Okay, let's do the next one. All right, we're supposed to add, so the next one we're going to add 3c cubed minus c plus 11 plus c squared plus 2c plus 8. So let's group the like terms together. And I won't do it up and down this time. I'll just do it horizontally. So 3c cubed is a term, and c squared is a term, and minus c is a term, plus 2c plus 11, and then plus 8. Well, if you add those together, you get 19, and here you get 2c minus c is c, and here you have c squared and 3c cubed, and they can't be combined. So in the end, we simplify it to say we have 3c cubed plus c squared plus c plus 19. And that's your final answer. So I put these two together here, but really they don't belong together. They're just on top of each other. So let me make that clearer here. So you're going to have 3c cubed, and you're going to have c squared. And then here's your c column, and here's your constant column. Okay, let's do one more, and then we'll do some subtraction. So we add 2c squared plus 6c plus 4 plus 5c squared minus 7. Well, I think I will put those on top of each other just so you can see. 2c squared plus 6c plus 4 over 5c squared, and I'm just grouping them by the exponents, and we're adding. So 2c squared and 5c squared makes 7c squared. And then there's nothing in this term, or in this polynomial in the c section, so you have just plus 6c. And then you have plus 4 and minus 7, which is minus 3. And that's your final answer. Okay, let's do a little subtraction. So here we have g cubed minus 2g squared plus 5g plus 6 minus g squared plus 2g. Well, because I don't want to get mixed up with the minus signs, I like to do it, I'll show you, we call additive inverse. So in other words, take, distribute the minus sign across the terms. So that's g cubed minus 2g squared plus 5g plus 6. And then if you distribute the minus sign, you have minus g squared minus 2g. And then we can begin the process of moving everything into groups, combining like terms. So that's g cubed, and we have 2g squared, minus 2g squared, and minus g squared, so that's minus 3g squared. So note, I'm approaching these like by the power of the exponent, because then it puts me automatically into the standard form, or in the form where the highest exponent is first, and then so on down the line. So here's 5g and minus 2g, so that's plus 3g. And then plus 6 is the constant. So that's what you have there. Okay, here's another one. Now I'm going to distribute this again because I think it's easier for me to look at this way. So even if I do it one on top of the other, 4y cubed minus 2y plus 8, I say, all right, this is actually going to be a plus, and then we would say minus 4y cubed minus 3y oh, minus 3y squared. Okay, we don't have a 3y squared on the top. And then minus 5. So 4y cubed plus minus 4y cubed plus minus 4y cubed is minus 8y cubed. Negative 2y. Oh wait, but we have first this negative 3y squared. So I'm going to do minus 3y squared. And then I'll do minus 2y. And then plus 8 minus 5 is plus 3. So now I've grouped the like terms and I've simplified, and this is what I come up with. Okay, one or two more, and then we'll leave you to the homework. So here we go again. The subtraction, where you distribute the negative sign. So 2x plus 3x squared and I'm going to make this a plus now, plus negative 7 plus 8x squared. And then I have, minus 7 plus 2x plus 11x squared. But I want to put this in standard form. I want to put this from the highest exponent to the lowest. So I'll say, okay, it's 11x squared plus 2x minus 7.